This is a video on the limit definition. The question states, use the limit definition to find the partial derivative of f with respect to y with f of xy equals x squared minus xy minus y squared. So let's first recall the limit definition of the derivative for a partial derivative with respect to y. And it says that the partial derivative of f with respect to y is equal to the limit as delta y approaches 0 of f of x comma y plus delta y minus f of xy all over delta y. So f of x comma y plus delta y, to find that, I plug in y plus delta y where I see a y in my function. So I get still an x squared, and then minus x times, instead of y, I have y plus delta y. And then minus, instead of y, I have y plus delta y squared. And then I have f of xy, which was x minus xy minus y squared. So I put that in. And then all over delta y. My next step is to just multiply the x through and FOIL this out, and then multiply the negative through. So I still have my x squared. I have minus xy, and then minus x times delta y. And then I FOIL y plus delta y, and then change the sign or make them all negative because of this minus sign. So I get minus y squared, and then minus 2y delta y, and then minus delta y squared. And then I have minus x squared minus xy minus y squared. So I change the signs, and I get minus x squared plus xy, and then minus a minus is another plus y squared, all over delta y. So now let's see what I can cancel. I have an x squared and a minus x squared. Those cancel. I have a minus xy and a plus xy. Those cancel. I have a minus y squared and a plus y squared. Those cancel. So notice all the terms cancel that don't have delta y's in them. And what I'm left with is the limit as delta y approaches 0 of negative x delta y minus 2y delta y minus delta y squared, all over delta y. Each of these terms have a delta y in them, so that means I can divide each of these by delta y. Negative x delta y over delta y is negative x. Negative 2y delta y over delta y is negative 2y. And minus delta y squared over delta y is just minus delta y. So I'm left with the limit as delta y approaches 0 of negative x minus 2y minus delta y. As soon as I've canceled the denominator, it's time to plug in. So I plug in 0 where I see a delta y, and I'm left with negative x minus 2y. So I can say that the partial derivative of f with respect to y, when f is x squared minus xy minus y squared, is negative x minus 2y. And I'm done with the problem.